there is an error in the calculation of power cost. Let's review the correct method. The problem involves calculating the annual cost of power consumption based on a given kilowatt-hour rate and power usage. The initial step is to convert the cost per kilowatt-hour expressed in cents to the cost per watt-hour. This is done by dividing the cost per kilowatt-hour by 1000, since there are 1000 watts in a kilowatt. In this case, 8.6 cents per kilowatt-hour is divided by 1000, resulting in 0.86 cents per watt-hour. This value represents the cost of using 1 watt of power for 1 hour. The next step involves multiplying the cost per watt-hour by the power consumption in kilowatts to determine the cost per hour. Here, the power consumption is given as 0.1728 kilowatts. To ensure consistent units, we will keep this number in kilowatts, however the monetary unit will change. Multiplying 0.86 cents per watt-hour by 0.1728 kilowatts yields 0.1486 cents per hour. This is the cost of running the device consuming 0.1728 kilowatts for 1 hour. To calculate the daily cost, we multiply the hourly cost by 24, since there are 24 hours in a day. Multiplying 0.1486 cents per hour by 24 hours gives 0.35664 cents per day. This is the cost of running the device for an entire day. To find the annual cost, we multiply the daily cost by 365, the number of days in a year. Multiplying 0.35664 cents per day by 365 days results in 13.1736 cents per year. This is the total cost of running the device for a full year, expressed in cents. Finally, to convert the annual cost from cents to dollars, we divide by 100, since there are 100 cents in a dollar. Dividing 13.1736 cents by 100 gives $0.1302 per year. Therefore, the correct annual cost is approximately 1302 cents, or 13 cents. It's crucial to pay close attention to units during the calculation. Converting kilowatt-hours to watt-hours and keeping track of cents versus dollars is essential for accuracy. Firstly, carefully review the problem statement to ensure a clear understanding of the given values and what needs to be calculated. Secondly, identify the appropriate formulas and conversion factors required for the calculation. Thirdly, perform each step of the calculation meticulously, paying attention to units and significant figures. Fourthly, double-check the calculations to minimize the risk of errors. Fifthly, interpret the final result in the context of the problem and ensure that it makes sense. Always double-check your units to make sure they align properly. For example, if you are working with power in kilowatts, ensure that the energy consumption is also expressed in kilowatt-hours, and the rate is given in terms of cost per kilowatt-hour. If there is a discrepancy, make the necessary conversions before proceeding with the calculation. Accuracy in unit conversions is crucial for obtaining a correct result. Remember that there are 1000 watts in a kilowatt and 100 cents in a dollar. When calculating the cost of electricity, it's important to consider all factors that contribute to the overall expense. This may include energy consumption, demand charges, and other fees imposed by the utility company. Be sure to include all relevant costs in your calculation to obtain an accurate estimate of the total expense. In addition to mathematical calculations, it's also important to consider the practical aspects of electrical installations. This includes understanding the National Electrical Code, or NEC, requirements for wiring, grounding, and overcurrent protection. Familiarize yourself with relevant NEC articles and tables to ensure compliance with safety standards and regulations. Let's examine several factors that can affect power cost calculations, requiring careful consideration and adjustment to ensure accuracy. The efficiency of electrical equipment plays a crucial role in determining power consumption and associated costs. Inefficient appliances and devices waste energy, leading to higher electricity bills. When calculating power costs, it's essential to consider the efficiency rating of the equipment being used. A higher efficiency rating indicates that the equipment consumes less power to perform the same task, resulting in lower operating costs. Energy-efficient appliances and lighting fixtures can significantly reduce electricity consumption and lower overall power costs. Investing in energy-efficient equipment can lead to long-term savings and a reduced environmental footprint. Demand charges are fees imposed by utility companies based on the peak demand for electricity during a billing period. These charges are typically applied to commercial and industrial customers with high energy consumption. Demand charges can significantly increase electricity costs, especially for businesses with fluctuating energy demands. When calculating power costs for commercial or industrial facilities, it's essential to consider demand charges and implement strategies to minimize peak demand. Load management techniques, such as shifting energy-intensive activities to off-peak hours, can help reduce demand charges and lower overall electricity costs. Electricity rates can vary significantly depending on location, time of day, and consumption levels. Utility companies often offer different rate plans to accommodate various customer needs and usage patterns. Time of use rates, for example, charge different rates for electricity depending on the time of day, with higher rates during peak demand period. When calculating power costs, it's crucial to use the appropriate electricity rate for the specific location, time of day, and consumption level. Understanding the different rate options available and selecting the most cost-effective plan can help minimize electricity expenses. Power factor is a measure of how effectively electrical power is being used in the circuit. A low power factor indicates that a significant portion of the electrical power is being wasted, leading to increased electricity costs. Power factor correction techniques, such as installing capacitors, can improve the power factor and reduce energy waste. When calculating power costs for industrial facilities with inductive loads, such as motors and transformers, it's essential to consider power factor and implement measures to improve it. Improving the power factor can lead to lower electricity bills and improved overall energy efficiency. Voltage variations can affect the performance and efficiency of electrical equipment. Significant voltage drops can cause equipment to operate inefficiently or malfunction, leading to increased energy consumption and higher electricity costs. It's essential to maintain proper voltage levels in electrical circuits to ensure optimal performance and efficiency. Voltage regulators and transformers can be used to stabilize voltage levels and prevent voltage drops. When calculating power costs, it's important to consider voltage variations and implement measures to maintain proper voltage levels. Ambient temperature can affect the performance and efficiency of electrical equipment, especially in extreme environments. High ambient temperatures can cause equipment to overheat, leading to reduced efficiency and increased energy consumption. Conversely, low ambient temperatures can cause equipment to operate inefficiently or fail. It's essential to consider ambient temperature when calculating power costs, especially for outdoor installations or facilities with temperature-sensitive equipment. Proper ventilation, insulation, and climate control measures can help mitigate the effects of ambient temperature on equipment performance and efficiency. Regular maintenance and upkeep of electrical equipment are essential for ensuring optimal performance and efficiency. Neglecting maintenance can lead to equipment malfunctions, reduced efficiency, and increased energy consumption. Regular inspections, cleaning, and lubrication can help prevent equipment failures and prolong the lifespan of electrical equipment. When calculating power costs, it's important to factor in the cost of maintenance and allocate resources for regular upkeep. Investing in preventive maintenance can help reduce energy consumption, lower electricity costs, and improve overall reliability. Energy audits are comprehensive assessments of energy consumption patterns and energy efficiency opportunities. Energy audits can help identify areas where energy is being wasted and provide recommendations for improving energy efficiency. Conducting regular energy audits can help businesses and homeowners understand their energy consumption patterns and identify cost-saving opportunities. The audit should consider the operational IOs of the equipment and systems under scrutiny. Factors such as occupancy schedules, production cycles, and lighting requirements can significantly impact energy consumption. For instance, a building occupied primarily during daytime IOs may have different energy profiles compared to one operating around the clock. A thorough assessment of operational IOs helps refine energy consumption estimates and identify opportunities for optimization. Understanding the different tariff structures offered by utility companies is crucial for making informed decisions about energy procurement. Tariffs can vary based on factors such as time of use, demand charges, and contract terms. Evaluating tariff options and selecting the most appropriate plan can result in substantial cost savings over time. Factors to consider when assessing tariffs include peak demand charges, off-peak rates, and contract duration. Utility companies may offer incentives and rebates for implementing energy-efficient measures, such as installing high-efficiency equipment or adopting renewable energy technologies. These incentives can help offset the initial costs of energy-efficient upgrades and accelerate the payback period. Researching available incentives and rebates can significantly improve the financial viability of energy-efficient projects. Consider any discounts for using renewable energy sources. Renewable energy sources such as solar, wind, and hydroelectric power offer opportunities to reduce reliance on fossil fuels and lower electricity costs. Investing in renewable energy systems can provide long-term cost savings and environmental benefits. When evaluating renewable energy options, consider factors such as system size, energy production potential, and available incentives. Power quality issues such as voltage sags, surges, and harmonics can adversely affect the performance and efficiency of electrical equipment. These disturbances can lead to equipment malfunctions, data corruption, and increased energy consumption. Implementing power quality solutions such as surge suppressors, voltage regulators, and harmonic filters can mitigate these issues and improve the reliability of electrical systems. Ensuring that electrical equipment is properly sized and matched to the load requirements is essential for maximizing energy efficiency. Oversized equipment consumes more energy than necessary, while undersized equipment may not be able to meet the load demands. Proper sizing ensures that equipment operates at its optimal efficiency point, minimizing energy waste and reducing electricity costs. Monitoring energy consumption patterns and tracking key performance indicators, or KPIs, can provide valuable insights into energy usage and identify areas for improvement. Data-driven decision-making enables businesses and homeowners to make informed choices about energy management and optimize their energy consumption. Energy management systems and analytics tools can facilitate data collection, analysis, and reporting. Building automation systems, or BAS, offer centralized control and monitoring of building systems such as HVAC, lighting, and security. BAS can optimize energy consumption by automating control sequences, scheduling equipment operation, and responding to changing conditions. Integrating BAS with energy management systems can provide comprehensive insights into building performance and identify opportunities for energy savings. Engaging employees and occupants in energy conservation efforts can create a culture of sustainability and drive meaningful reductions in energy consumption. Employee training programs, awareness campaigns, and incentive programs can encourage responsible energy use and promote energy-saving behaviors. Creating a collaborative environment fosters a sense of ownership and accountability for energy management.